Have you ever been working on a program only for it to suddenly stop without warning, leaving you wondering what happened? It is a common experience in software development. Code execution flow terminates prematurely primarily when an unhandled error or exception occurs, or when a critical system signal is received that forces the process to halt. This means the program stops before reaching its intended endpoint. The most frequent cause is an unhandled exception. An exception is an event that disrupts the normal flow of a program. Many programming languages like Java and Python use exception handling mechanisms. When an operation cannot be completed successfully, perhaps due to invalid input or a resource not being available, an exception is raised. If this exception is not caught and managed by specific code blocks designed for error handling, it propagates up the call stack. The call stack is a mechanism for a program to keep track of where it is in an execution. If the exception reaches the top of the call stack without being handled, the operating system intervenes and terminates the program to prevent further unpredictable behavior or potential data corruption. This process is known as an unhandled exception and results in an abrupt cessation of execution flow. Other reasons include fatal errors that cannot be recovered from by the program itself, such as running out of memory or a segmentation fault, which indicates an attempt to access restricted memory. Operating systems can also send signals, for example, a termination signal, that instruct a program to exit immediately, regardless of its current state. To understand why your code terminated, you should first examine the program's output. Many systems will provide a stack trace, which is a report of the active stack frames at the point of an error. This trace lists the sequence of function calls that led to the problem. Carefully reading the stack trace can often pinpoint the exact line of code and the nature of the unhandled exception that caused the premature termination. Looking for keywords like null pointer exception, array index out of bounds, or division by zero can guide your investigation. Understanding the anatomy of an unhandled exception, particularly the concept of call stack unwinding, is crucial for effective debugging. When an exception is thrown, the program effectively unwinds the call stack, popping functions off until it finds a suitable handler or reaches the program's entry point, leading to termination. Knowing this helps you predict where to place error handling logic, such as try-catch blocks, to gracefully manage errors instead of letting them crash your application. This proactive approach transforms unexpected stops into manageable events. By recognizing that premature termination is often a signal of an unhandled error propagating through your program's execution layers, you gain powerful insight into debugging. This knowledge allows you to strategically analyze stack traces, implement robust exception handling, and ultimately build more reliable and resilient software that gracefully navigates unexpected conditions.
If this helps you fix faster, like, subscribe, and keep debugging with us.